Hello, everyone, and welcome to our second part presentation, Understanding Human Mind, not a trivial or easy task to do. Last week was part one of this presentation, and in this first part we were touching on psychology of the humans and behavior of the humans. This second part is dealing mainly with practical impediments to understanding of the human mind. The first one we can list is lack of psychological primitives. Any model of the mind, right or wrong, must necessarily define fundamental elements or components from which to build on its explanations. Such psychological primitives include consciousness, concepts, tasks, sensory inputs, memory, phenomena, attention, and so on and so on. All of these are, of course, human conceptualizations based on what we have observed in ourselves and may not reflect any real neuroanatomical structures in the brain. Moreover, all primitives have porous boundaries that bleed into the nearby ones. For example, declarative memory overlaps with the process of generalizing via concepts. Alternatively, it can be seen as an instance of episodic memory that has been entrenched through repetition. This and other ambiguities imply that the primitives discovered so far are only ad hoc rules of thumb and that they have broad, though not universal, applicability. They are not an artificial foundation for a system, at least nothing ironclad, immutable, and which applies without exception. Primitives are always defined and only make sense within a context of assumptions regarding what they will be used for. Much of the confusion in defining primitives stems from the theoretical frameworks of which a given primitive is a part, including the four theories of purpose described in the part one presentation. For example, if you believe that the mind is an information gathering and world modeling machine, as described in paradigm 3, then all memories are pieces of some world model. They're never ad hoc inventions relative to the needs of the agent. On the other hand, if you believe the mind intends towards spiritual growth, then every memory of an experience is instructive in the Jungian sense. There are no accidents in this. Even when you concoct a set of primitives that are true in general, they may still not be instructive for building a mechanical model of the mind. For example, it goes without saying that a sufficiently well-functioning mind intends towards its benefit, or what it believes is its benefit, be it psychological, spiritual, emotional, or social. But defining what benefit means, how it evolves over time, how the mind knows it has achieved a given benefit, and how to resolve conflicts between two such benefits is left vague and difficult to implement. As another example, it is clear that the mind generalizes from previous experiences to new ones, but how it does so successfully and how it knows when a generalization is appropriate is as yet unclear. So we will be looking at introspection considered perilous. The mind presents many internal roadblocks to a full exposition of what it does. Notably, it tends to adapt in exactly the wrong ways as to undermine any theories we may build about it. For example, once it is well known that humans are subject to certain psychological tricks and fallacies, like, for example, perceptual biases or marketing tricks, those who become acquainted with this fact develop defenses against them and may make the tendency largely disappear. Critical thinking has always been the study on how to overcome such all-too-human foibles. And the mind appears limitless in its ability to adapt in opposition to any pattern claimed about it. As a consequence, all theories of cognition are only probabilistic, more applicable to those individuals who are not yet aware of their own limitations. Sometimes an individual may even choose to act contrary to spite any predictions made about it. And as Dostoevsky famously pointed out, there is one case, the only when men may consciously, purposely desire what is injurious to himself, what is stupid, very stupid, simply in order to have the right to desire for himself even what is very stupid and not to be bound by an obligation to desire only what is sensible. So that was a quote from Dostoevsky, and like his work Notes from the Underground. Another challenge to data collection is that much of what your mind does is invisible to introspection. This is unfortunate, since introspection and self-report are the primary tools we have for mapping cognitive functions. Even MRI scans are only useful if you know how to interpret the electrical graphs with respect to a background theory. So having a cognitive theory is a necessary prerequisite to MRI research. These theories are frequently laden with biases they have inherently from folk psychology and older schools of philosophy. For example, the popular split between episodic memory and declarative memory may be an echo of the traditional split between subjective and objective understanding of the world, a split that has since been called into question by postmodern semiotics. And philosophers like Daniel Dennett spent much of their career trying to undo our preconceptions to the singular controller in our brain, a bias that our culture has carried with it via a long tradition of social and political identity formation. Well, a little information introspection gives us may also be misinterpreted. The timing and continuity of mental events are difficult to gauge. We may see as continuous and gradual what is actually a series of punctuated, erratic, and random steps. For example, a concept like a sandwich may be viewed as a singular, unified mental entity, yet the appearance of ambiguous cases like hot dog suggests that concepts are more a process of case-by-case evaluation than a static entity. And then we have the case of sluggish language. All understanding of the mind must be done within the constraints of the human mind. And since the result is ultimately expressed in a descriptive symbolic language, researchers are subject to the limitations of existing conceptual systems, and these are slow to change. Definitions of psychological concepts carry historical implications and connotations that are difficult to erase from the works and words that we use. Like word like unconscious still harbors Freudian and Jungian implications. Each English word has evolved in the concept of certain assumptions regarding how it will be used, which give the word its meaning. For example, the definition of memory connotes that its purpose is to be an accurate description of the way the world is as presented to the senses. This makes it impossible to talk about a type of memory that is relativistic or functional, a memory that is meant to serve a purpose and this is as much as a fabrication as it is a record of events. There may simply not be the right words to describe how the mind, as it actually is, at least not until new paradigms have been laid out first. What applies to language also applies to scientific theories. Normal sense, as described by a philosopher called Kuhn, can only proceed on the basis of shared assumptions of what to focus on and how to frame and interpret experiences. And since the progress of science depends on peer review and therefore a peer approval, popular paradigms are slow to change by default. Scientists will usually research topics they suspect other scientists will find interesting, using terms their contemporaries will understand and concepts they're familiar with. The act of changing fundamental concepts and assumptions is never the work of normal science itself. One must look outside of it to like for example philosophy. And then we have combinatorial complexity. One last practical roadblock to a description of what the mind does is that nearly all events in an individual psyche have their own complicated history. The question, why did I think of an elephant just now, can never have a general answer. This dependency on history is more true of the brain than of any other organ. The brain can be broadly seen as an organ of memory, incorporated the past into the present, although other organs also incorporate the past to a limited extent, like for example muscle memory and muscles growing larger with strenuous exertion. The brain is perhaps the only one that makes history of its primary subject matter. Exploring such a stateful system is a complicated task, since to explain any individual thought or behavior, we must trace it through its unique causal pathways. And this may have left no breadcrumbs for us to follow. Small differences can have enormous consequences. Weight training may make the difference between being able to lift 50 pounds or 100 pounds, but education can make the difference between making a bow and arrow and making an atomic bomb. Even if the necessary equipment and resources are available to a person in both cases, the words you say and actions you take will vary greatly based on small differences and past experiences. And so this is the end of this presentation, and we cannot be sure that we include everything. So feel free to add suggestions and recommendations if you wish. Across all of these examples, one thing remains constant. Any theory of the mind must fit into and be formulated according to the limitations and quirks of human understanding. It may seem as if to understand the mind, we must possess a nearly perfect mind ourselves, which is a tall order, and unlikely to be satisfied by any flesh and blood researcher. Fortunately, this is not a really requirement. An awareness of these pitfalls, along with a willingness to compensate for them through the help of others with complementary strength, has always been the best path forward for theoretical progress. And with this said, I'm ending this presentation, and I'm coming back to the beginning of this presentation, where I had to tell you that my name is Paul Arsov. I'm the founder of the Decentralized Web Project. We currently are working on 3 different projects. The first project that I want to mention is the Decentralized Web Project, and we're building decentralized communication and advertising platform. We did release a complementary project to this project with a marketplace and collection of NFTs. What is interesting, special and unique about these NFTs is that they're based on three-dimensional objects. With three-dimensional objects, there has to be special software which loads the object in window, and then it displays the loaded file of the three-dimensional object. Usually 3D object creators are using standard software, and there are two very popular choices for displaying of 3D objects. Both of them are game engines, and one of them is called Unity, the other one is called Unreal. But from the very beginning in our project, we decided to build our own 3D software engine. And what this software engine does is it reads the file of the 3D object, then it opens a window in a computer screen, it loads the 3D object in this window, it open, and then it starts animating this 3D object within the window in a way of moving it in a random fashion. But in addition to loading, displaying and animating of the 3D NFT, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D NFTs and 3D software engine is the capability of speaking. Our 3D NFTs can speak in one of three different voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, the 3D NFTs can speak in different flavors of voices. A voice can be spoken either in a normal speed manner or in a fast speed manner or in a slow speed manner. And if, for example, we take a voice and it is spoken in a fast speed manner, we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. If on the other hand we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a masculine person or the voice of an old person. The second additional important capability for our 3D NFTs is the capability of voice recognition. Our 3D NFTs can recognize voice commands, and like for example, if we have a 3D NFT which is animated and constantly moving, then we can issue our very first voice command to this 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. Then we can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go farther away, zoom out, and start rotating. The next additional important capability for our 3D NFTs is the capability of them having basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply with who they are. You can ask the 3D NFT to describe something like like describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or about decentralization or about the country called Russia. The last but not least important capability for our 3D NFTs is the capability to display them in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our to our 3D NFT marketplace, and probably now is the time to tell you the name and the URL of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is altogether 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're typed all together, decentralized web. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of the main page, and like any other page, you can see number of links, and one of these links is pointing to links to accessories. When you click on this link, you're going to see that we are offering special glasses. You can click and order one pair of these glasses, and when you receive these glasses, you can see that one lens of these glasses is red and the other lens of these glasses is blue. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and you're going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D NFTs collection and 3D NFT software engine, but I like I like to tell you a little bit about the 3D NFT marketplace. In our 3D NFT marketplace, we have special. We have our own blockchain instance, and this blockchain instance runs the standard Ethereum software. This is the same software which runs on Ethereum mainnet. It runs on blockchain on Binance Smart Chain. It runs on Polygon Matic Chain. It runs on Avalanche AVAX chain, and it runs on many other famous and not so famous blockchains. By having our blockchain instance, then we do not require our users to pay gas fees for the deployments of the smart contracts for the non-fungible tokens, and our users do not pay fees for transactions of transfer of ownership from one user to another user. By having our own blockchain instance, then we also allow our users to use multiple crypto coins for buying and then receiving proceedings from sale of our 3D NFTs. Currently, we have four different choices of crypto coins which our users can use for purchasing and selling for our 3D NFTs. The choices include Solana Sol, Polygon Matic, Avalanche Avax, and KuCoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to these four different coins, we have second parallel and independent way of buying and selling of 3D NFTs, and it is done entirely in fiat currency. Like I can give an example, like for example, if you're a user and you come to our 3D NFT marketplace, you click on the composite image of our first collection, then you are going to see all of the NFTs in our first collection listed one after another. Let's say you see one 3D NFT that you particularly like, you click on it, then you are going to see a short video of this 3D NFT as it is moving, and below this you are going to see a drop-down menu which presents the four different choices of paying with crypto coins, or the fifth choice of paying with fiat currency. So let's say you select this choice, then you click on the button to advance next. You're going to be asked to put the number of your debit or credit card, expiration date, CVC, and when you click and complete the payment, what is going to happen is there is going to be a transaction and conversion from your national fiat currency to US dollars, and this payment is going to be deposited in our bank account. We're going to follow this action with a transfer transaction, and this transaction is going to transfer the initial ownership from our 3D NFT marketplace to you, and now you become the first user and owner of this 3D NFT. You can play with this 3D NFT for a while, and then at some point you can put this 3D NFT for sale. Then you can, let's say there's a second user who comes to our 3D NFT marketplace. They browse through the 3D NFTs, and they like in particular the 3D NFT that you just put for sale. So the second user, let's say they click on this 3D NFT, they're presented with the same drop-down menu of payment with crypto coins or payment with fiat currency. So let's say they select paying with fiat currency, they click on the button to advance next, they put their debit or credit card, and they click to complete the transaction, and then the payment is going to be converted from the national fiat currency of the second user, which could be different than your national fiat currency and different than US dollar, and it's going to be converted to US dollars and deposited in our bank account. We're going to follow this action with second action, and transfer of the ownership from you, the current user, to the second user, and now the second user becomes current owner of this 3D NFT. Then we're going to follow the second action with the third action, and a transaction, and a transfer from our bank account conversion from US dollars to your national fiat currency, and the payment for the sale of this 3D NFT is then going to be deposited in your bank account. With this said, I'm ending talking about this first project. I'm going to mention the second project, and this second project deals with electric power and handling charging of electric vehicles with electric power. Currently, the charging of electric vehicles is done in a way that resembles the way internal combustion engines are loaded with fuel. Internal combustion engines vehicles, they're coming to special locations called gas stations, and where the owner of this vehicle puts like a hose to their vehicle. They start fueling their vehicle. They put like their debit or credit card, they make a payment, and then they leave. In the same way, currently there are electric power stations which have limited number of columns, and electric vehicles are coming to these stations, and they connect electric power cables to their vehicle. The vehicle starts charging. The user is making a payment with their debit or credit card, and they stay for a while their vehicle is charging, and then they're leaving. But we estimate that ultimately the number of electric vehicles is going to become insufficient to handle the charging of these electric vehicles, and it's going to be necessary to provide different methods and different ways of charging electric vehicles. We are working on products, and we're proposing a model for charging electric vehicles where the vehicle can be charged in the way of at a location at the location of the parking lot, and this parking lot could be either the place they're living or the place they're working. Like for example, at the place they're living, the owner, if they're living in a high-rise building, like most often this high-rise building has a ground floor or multiple underground floors with parking lot, and the owner of this vehicle comes in the evening, and they're leaving their car during the evening, night, and early morning in this parking lot. In the same way, the person who is owner of an electric vehicle, they may be working in an office building, a high-rise office building, and in the same way this high-rise building may be having a ground floor parking or multiple underground floors for parking. In the same way, the person who is leaving their vehicle in this office building, they leave their vehicle during the morning, afternoon, and maybe early evening in this office building. So we're working on products which could be mounted at the parking lot locations, and they could load electric vehicles with electric power, and this electric power could uh, like these electric vehicles could be left connected during the time the person is in the office building, or during the time the person is at home. And this significant amount of time, and either just home time or home plus work time may come close to 24 hours in being able to charge their vehicle up to close to 24 hours a day. So we are working on a product which includes electric power switch. It includes remote connection um, remote connection capabilities. It includes near-field communication, which can read either a credit card or debit card, or certain near-field communication tokens, which could be in the shape of a credit card or a keychain token, or a ring which the person can wear on their finger. And with this near-field communication card, be it payment card, debit, credit, or normal near-field communication card, the user can identify themselves. Then this is going to remotely trigger switching of the electric power, and the person can then connect the charging cable to their vehicle. With this said, I'm going to tell you the name and the URL of the website for this project. It is called power.arstec.com. Power is the only ordinary word for power. Then there's dot. Then there's a word which sounds like Arstec, and I can spell it letter by letter. It's Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether, Arstec. Then there's dot, and it ends with com. In our website, we release 3 different surveys on software, hardware, and features. You're welcome to click on one or more of these surveys, fill these surveys, and it is going to give us an idea if you like to have a specific and custom product that we can build, or we can customize an existing product to fit your requirements. We have also a number of articles that you can read, and the page for the initial concept product, which you can look at the features and options that it has. That's it for the second project that we work on. And the third project that we work on is called Element of Artificial General Intelligence. It is a project which includes several different technologies. It combines them into like a packet of technologies, and this combined packet of technologies could be customized to multiple different intelligence devices, and we plan in the future to incorporate it in a robotic device which can include speaking, voice synthesis. It will include voice recognition. It will include computer vision. It will include movements, object detection, object classification, and etc. and etc. We did not yet release a website for this project, but we did handle the computer synthesis, like video and audio input and output, and we are currently working on the voice recognition capability, and the interesting thing about this is that we are doing this in a way that is different than current ways based on machine learning models. So what we are proposing and what we are building is, like, for example, you say a word, then this word is having recorded audio, and then you can select or type a text, and this text is associated with the audio. This is the first sample, and based on this single and first sample, then we can start recognizing the same word if it's spoken in the same fashion. So traditional machine learning does extensive training, and it may use thousands upon thousands of hours of audio to analyze it in order to start the voice recognition. Our voice recognition is based on a very clever algorithm, and this algorithm allows us to start voice recognition just with a single and one sample, and then start building upon this sample for recognizing the same word. With this said, I'm ending this presentation. Thank you for viewing. Thank you for looking. Have a nice day. Have a nice evening, and goodbye.